Okay, so today we're going to go ahead and we're going to talk about the gas laws. Okay, and the first thing to define in the gas laws would be what is the definition of pressure? Because pressure is going to be important when we're talking about gases and how gases behave. So, by definition, pressure is not when you're taking an exam, but it's the result of a force distributed over an area. So, the force distributed over the area is the definition of pressure. Now, when it comes to a gas, gases are constantly moving around at a high speed, like we've discussed in the previous section. Okay. As those gases move around and they bounce off of each other and collide in their enclosed space, they cause more pressure. So, in a closed container, gases exert pressure when those particles of gas collide not only with each other, but in the walls of the container. And the less room that they have, the more pressure there's going to be, which we're going to talk about in a second. So, let's talk about all the different factors that affect the pressure of a gas. Okay. Well, first of all, pressure can be affected by temperature. When you raise the temperature of a gas, you're going to cause that gas to have more energy and move around faster, like it says here. Okay, if you increase temperature, the particles are going to move around faster. When the particles move around faster, they're going to collide with the walls and with each other more frequently. We said that the more that those particles collide, the higher the pressure is going to be. So if you increase the temperature and you're causing those particles to collide more frequently, you're going to, as a result, increase the pressure. The second factor is going to be the volume, okay? The more space that a gas has to move around in, the less likely it is that they're going to collide with the walls or with each other. The less space they have, the more likely it is they're going to collide with the walls of each other. So if you decrease the volume and you have less space, those particles are going to collide more often, which results in, again, an increase in pressure. The last will be the number of particles. Obviously, the more particles you have, the more often those particles will collide, right? If you have less particles of gas, then they're going to collide against each other in the walls less often. So if you increase the number of particles, the particles are going to collide with the container more often, and you're going to increase the pressure. So to recap, an increase in particles will increase pressure, an increase in temperature will increase pressure, and an increase in volume is the only one that's different that will decrease pressure. These are the three major things that you want to learn from this section. The next step is it's going to talk about the gas laws, which explain all of these things. So Charles' law says that the volume of a gas is directly proportional to the temperature. Okay, so increase in temperature will lead to increase in volume as far as the gas goes. So volume 1 divided by temperature 1 equals volume 2 divided by temperature 2. This is what Charles' law looks like. And if you look at it as a visual, it actually makes sense, right? Right here, you see the temperature increasing. As the temperature increases, the gas moves around more. It expands, right? So the volume of the gas will increase as well along with the temperature. The second law is going to be Boyle's law. Boyle's law states that the volume of gas is inversely proportional to pressure. So if you increase the volume times 2, you're going to decrease the pressure by a half. We express this with pressure times volume 1 equals pressure times volume 2. So what this basically says with a visual, if you look at this, the more space you have, the less pressure there's going to be, right? So it's inversely proportional because what this tells you in Boyle's law is that as the pressure goes down, the volume goes up. Or we should say that as the volume goes up, the pressure goes down, right? So right here, we have a little space, right? There's not that much. There's not that much volume. Because of that, the gas particles are bouncing around a lot and colliding with each other, so the pressure is very high. As you make more space and you make more room, that pressure is going to go down because those particles will have more space to move, which means that they're going to hit the walls and each other, less likely decreasing the pressure. If we combine these two gas laws into the combined gas law, which is the main law of this, what you do is you have this expression, pressure times volume divided by temperature equals pressure times volume divided by temperature. Okay. And this law sums up everything we just talked about and relates temperature, volume, and the pressure of a gas and the relationship that that serves. This section is not very long, but it's very important that you understand some of this, and that most importantly, you understand what your two gas laws are, as well as what pressure is, and how temperature, volume, and number of particles all affect the pressure of a gas.